So hey everyone, thanks for joining. Welcome to our joint webinar, tell you about how MoEngage maintains an extremely competitive SLA of 99.9 at a very high scale by reducing costs on AWS using Granulate and AWS solutions. With me today are guys, you can present yourselves. Aaron.
Hi everybody, my name is Zero and I'm a partner solutions architect at AWS.
Hey, I'm Balaji. I come from MoEngage. I work as a director of engineering here.
And I'm Omer. I'm a solution engineer at Granulate. Also worked with Balaji on our joint cooperation to reduce MoEngage's costs. So what we're going to go over today is basically go over Balaji's journey into reducing costs on AWS, tell you a bit about MoEngage, which is a very developed company in terms of saving costs and using state-of-the-art solutions running on AWS, and then walk through what AWS offers its customers in terms of performance improvement and cost reduction, and then talk about our mutual venture with Granulate and MoEngage to provide additional cost reduction and improve performance after using or exhausting all the resources that MoEngage could. So have fun, everyone. So Balaji, go ahead.
Okay, sure. Thank you, Omar. Hey, so hello everyone. So I'm from MoEngage. Let me talk about so how we get benefited by Granulate in terms of saving our CPU cost and decreasing CPU performance. We at MoEngage, basically we are into insights lead customer engagement platform where we help our customers to engage with their customers. And help our customers to grow and retain their customer user base. We have a different product suites which helps customer to engage with their customer through the channel of sending notification, being it in SMS or email or in-app or native. So we help our customer to engage with their customer through this notification channel, and we have a different product suites. Right now we are into the very crucial intersection of connecting the both AML and the customer engagement platform. So with MoEngage, so the customers can analyze their customers' behavior and then act on insights with the personalized messaging, whatever the customer preferred channel at the right time. So it can be used any major festivals or Black Friday to target the certain segment of people in terms of increasing the sale, or engaging with them, or sending the promotions. It helps. So right now, we are one of the top players in Southeast Asia into the customer engagement platform. So predominantly, we are the number one player in Southeast Asia. And so we have the clients and the user base across all other regions, especially in US and Middle East and Europe. Coming to the MoEngage, what scale we are dealing with is so right now we have a in-house store of 900 million monthly active data stores. The 900 million is very huge scale, which is of the scale of what Twitter handles. So so with the data, with the big data and analytics, we are able to churn the data and able to engage with at least 2 billion customers in a day. And in a month, we are sending more than 80 billion notifications out. So, so to handle this scale, we heavily relying on AWS as we more as a market leader in this growing customer engagement platform. We heavily relying on AWS usage, and with the rapid growth, also increase the demand for AWS infrastructure and rising the cost, especially in the CPU cost. So we spend a lot of dollars in terms of the CPU and the computations to deal with this massive data scale, handling 900 million monthly data store. So we were in we are the great challenge of one side optimizing our cost at the same time without impacting our developers' productivity or not changing any of our code base. So we are finding out solutions. So luckily, so we got to know the Granulate and then everything so get rolled on quickly. So with Granulate, so we are able to save thousands of dollars in our infra without making any code changes. Okay, that is what made it to us. And in the quick time, we are able to onboard Granulate very quickly and able to integrate and activate our agents without much hassle. And it was a very smooth transaction. So when it comes to the result, following the Granulate activations, as MoEngage, we could able to see the immediate performance improvement in our CPU utilization. I would say like up to 30 to 40% reduction in CPU utilization, or the reduction of 25% of our CPU cores in our infra. So that is what the result we have seen that as an immediate outcome.
Can you tell us a bit about the architecture?
Okay. MoEngage, as we handle such a big scale, to handle those scale, we are a Pythonistic, Python agnostic environment from the right from the founding the company. The reason the founder is able to write code and build the product, so we want to follow the same line. So now we become a Python agnostic environment, and at the moment we are running more than 130 microservices in our AWS infrastructure. It uses multiple AWS resources, not just EC2, and you name it, any other EC2, any other AWS feature, we are using it. And so other than EC2, so we heavily relying on SKS for receiving message and sending messages. And most of this workload happens on the spot instances. So luckily, we would be able to optimize all of our workload and infrastructure workload into the spot instances. So it's, I would say it's a more like a upstream, downstream data part, and we involve a lot of the data-driven and event-driven elements inside our architecture, and also we have a lot of decoupling inside our architecture, so that maintaining or making changes in one service will not impact in other code base. So right from the beginning, we are very clear that we have to run everything in service-oriented architecture with the very well decoupled manner in order to handle the disaster failure, any failure or any kind of scaling aspects. So we are focused on the microservice architecture right from the beginning.
Thank you. It's easy to see that MoEngage is very much invested in like using like top of the notch solutions and architectures and utilizing as much as the solution that's on the market to improve performance and run the again state of the art solutions and coverage in terms of cost reduction. And can you tell us a bit about the challenge? I mean, you mentioned it a bit. So as a company which is very much focused on growth and using a lot of services, I mean, what was the challenges you were managing with?
Sure. Yep. Sure. As I was mentioning, we are into the very crucial intersection of implementing AI/ML with our customer engagement platform. So while working on it, we don't have time to stay back and do any sort of cost optimization. One side we are growing our cost to the north of in a millions, two digits, millions in a year, and other side we have to grow our product suites and launch our product as early as possible. So we don't have time to sit back and rework on our current architecture to reduce the cost. So we were looking at someone can come and help us without impacting our developers' productivity or without making any changes in our code. So that's where the major challenge, because at this moment, so most of the players in the market provides the visibility to where to reduce the cost, but no one really does it underneath the infrastructure layer. So that was one of the very big challenges for us. So we have our own SRE team, DevOps team, who can focus on some of the internal elements of optimization, things like choosing the right instance type and running everything on spot instances, having the right auto scaling policies to upscale, downscale, in a faster manner. But still, we were worried about we are not able to optimize the CPU cost. The reason the Python, it's a single thread, it's a multi-threaded, but it's not a multi-processor. So we don't have a time to go back and re-architect our code base in any language where like a Java or Go to reap the benefit of better CPU utilization. So that was the biggest challenge we had. So luckily the Granulate came in and helped us to optimize the CPU utilization without making any changes in our code base. I think I thanks to the Granulate team for launching the tool, which helped us to make some optimizations. Not some, it's a very good optimization without making any changes in our code.
Thank you so much, Balaji. Thank you for giving us some details about the challenges that engineering teams and DevOps team are dealing with with MoEngage, and I think a lot more can relate to that. And now we have Aaron, which is a principal partner solution architect in AWS, which will walk us through the solutions and optimization opportunities that AWS offers to its clients, and MoEngage as part of those. So Aaron, go ahead.
Thank you, Omer. So as you mentioned, I'm going to talk a little about AWS cost optimization. So in terms of content for today, I will give an overview of cost optimization levers, how to be successful in lowering spending with AWS, and lastly, I will highlight some considerations when purchasing savings plans. Let's have a look at the commonly used optimization levers and tools. Just quick note, so there are a lot of cost optimization tools AWS provides. I'm not going to cover all of those today due to time limits. So this is just a quick overview of some of the ways you can lower your AWS costs. So not all cost optimization tools and activities are equal, and in fact, you should pick and work on those that make more sense to your business while deferring others to a later time or even not do at all. So we lay out the different activities to optimize in terms of complexity and impact. So things that are harder to do and require more effort are all the way to the upper right, while things on the bottom left are much simpler and faster to execute. However, things that are fast and simple to execute might not have much impact. So we will start off with storage. At the bottom left, we have Amazon S3 Intelligent Tiering. It takes a few clicks to turn it on, and what it does is for your storage on S3, there's a service that uses AI ML to automatically figure out if your objects should be in S3 standard tier, or can we move the objects to infrequent access tier, which costs less. It observes your access patterns on your behalf and make the switch automatically between the different tiers. So depending on how much you're spending on S3, this could be a really quick win to getting your first savings. On to compute. So instant scheduling is where we turn off your resources when you don't expect usage. Usually that's after office hours. So there's a solution called Instant Scheduler in the AWS Solutions Library. You would usually use this solution for your dev and QA environments where you don't need your servers up and running 24/7. Next, I would like to introduce you to two of the commercial levers. So that's savings plans and reserved instances. You can utilize them to obtain discount in exchange for commitment. And this is impactful because it can affect a lot of your spending. And if you don't know where to start, I recommend you to start here first. I'm going to cover the topic later on. On the far right side, we have right-sizing production workloads. So there's a free service called AWS Compute Optimizer that you can utilize today to help you identify oversized resources. The AWS Compute Optimizer uses machine learning to analyze your historical utilization metrics and make recommendations for the optimal AWS resources for your workload. And finally, you can apply more advanced cloud-native methods such as using spot instances, auto-scaling, serverless, and other cost-aware architecture. These activities are more engineering-focused, but they are extremely impactful. They are also usually longer-term projects and require upfront investment to re-architecture your workload. Spot is a bit of a special case where sometimes re-architecture isn't needed. and it's actually quite straightforward to do. So this graph aims to provide a better idea on how to classify your cost optimization activities, as well as providing a starting point. And all these activities are nice to know, but they are underpinned by two important building blocks. So the first one is cost awareness and visibility. So question to your team and perhaps yourself is, do you know what were you spending last month? If the answer is no, then it is most likely you can get benefit by having access to tools such as AWS Cost Explorer. This will provide you with information so that you know what you're spending, how it changes over time, and provides accountability on those spendings. The second is organizational behavioral mechanisms. So you will need some sort of mechanisms in place to get people to take action. So there's a behavioral model by Stanford University that talks about when an activity happens is based on if there's enough motivation, if there's enough ability, and people are prompted to do something. So let's make this more tangible. So from a motivation perspective, you need to have strong executive support to drive cost optimization activities and consistent communication to let the team know that this is top priority. In terms of ability, so providing your engineers with the right training and tools and providing engineers enough time to optimize spend will increase the chances of the activity happening. And finally, we look into providing the right prompt to get those activities started. So I find the most impactful and easiest prompt is to create a cost dashboard for individuals or teams. Ideally, they should represent the cost that the individual or team is responsible for. Also, equally effective is to create some sort of cadence, whether daily or weekly, where teams or individuals will go through their cloud spendings and understand if there are any unintended costs. So from the prompt perspective, it is super important to use a cost visibility tool. This can be as simple as a monthly AWS invoice that can be shared with the team. As you go along the line, the visibility tools get more complex and can cater to a much more dynamic environment. I recommend to start with number 3, which is AWS Cost Explorer and AWS Budget to provide you with required visibility and notifications for your team. So let's move on. So I would like to talk about, again, the two commercial levers, so reserved instances and savings plans, and when does it make sense to get savings plans. Let's start with reserved instances. So reserved instances provides significant savings of up to 72% discount versus on-demand. However, it does require planning and management to understand what is required, such as your instance family, instance size, operating system, region, availability zone, and tenancy. So that's reserved instances or RI. Moving on to savings plan. So there's one plan called EC2 savings plan. So with EC2 savings plan, part of this problem goes away. So you get the same kind of saving as you would have with reserved instances, but with lesser matching criteria. So here savings plan is concerned only on the instance family and region. All other criteria are gone away. And to put it in a sentence, you're essentially committing to a certain dollar per hour of instance family in a region. So for example, $5 per hour of C5 in Singapore region. Moving to compute savings plan. So compute savings plan is more flexible and require even less planning and management, but it provides lesser discount than the reserved instances or the EC2 savings plan. It doesn't matter if you change instance family, size, operating system, etc. As long as you maintain your commitment to spend X amount of dollars on compute, which by the way include EC2, ECS, EKS, EMR, Fargate, and also Lambda. And again, essentially, it's a commitment to AWS Compute globally. So again, $10 per hour on AWS Compute globally. All regions, all instance family, different services, as I mentioned. And with that, I'll hand it over back to Omer from Granulate to continue with today's session.
Great. So thanks, Aaron. That was super interesting. And I think what's interesting here is that I think MoEngage and the spectrum you presented between complexity and impact are really using the most complex and the highest impact infrastructure, very cost aware, heavily utilizing spot instances, SQS, of the top of the notch instances on AWS. And what we want to discuss now is that after a company like MoEngage really exhausted all it can found on the cloud, you might say, or in the solutions that allows it to reduce cost and optimize performance, which is very significant. What does it do now if it still needs to try and squeeze more additional performance improvement? And this is where other solutions come into place. And what I want to present now is to show you a bit the landscape that we operate in, and then present how MoEngage went about it when they got to the point that they needed additional workloads or additional improvements on their existing workloads. So when you look at additional solutions on the market that are not on AWS in terms of performance improvement and cost reduction, we're looking at a few, again, there's an axis here, but it's related to what's the amount of cost reduction you can achieve from which solution family. And the y-axis is how much can each of the solutions or each of those regions improve in terms of performance and cost. So first you have best practices and cost visibility and monitoring, which allow the company to get, again, visibility into their costs and be more aware of what they're doing, how they can spend their money more wisely. And MoEngage, of course, take huge advantage of that. Also in terms of getting visibility into their code and to use the best practices they can, Spot Instance, for example, or even others to reduce their costs. And you have, this is the more, I will say, manual or using money more smarter on the cloud and on AWS to reduce its cost. And then you have the more automation changes, which are configuration tuning. This means you will change parameters at the kernel or runtime level, or even at the instance level or cluster level to reduce your costs or to improve performance, but it's more tunable. You do one-time parameter changes, you improve your performance, it's a one-time thing, you improve, then you're off with it for future. And then the next types of performance improvement or cost reduction solutions are workload orchestration, resource orchestrations. These are solutions that basically allows you to reserve the correct amount of resources at the cluster level, whether it's per pod or number of nodes need to run on the infrastructure, in order to not have significant amounts of over provisioning and to actually realize the correct amount of resources compared with your actual consumptions. So these are solutions that actually, the cost optimization solution that actually improves cost or reduce cost pretty significantly, but it don't really affect performance. So you might reduce the number of resources you reserve per instance or per pod, but in terms of performance or how the cluster is actually performing in terms of metrics or job completion time, for example, it won't really have impact. It will just reduce the bill at the end of the month, which is of course important. And then there are solutions that what we call real-time continuous optimization that actually improve each machine's ability to run the load on the cluster. Those impact in both ways. They improve performance dramatically, so you can run the same job for less time or the same workload on the cluster with less machines. And you also get cost reduction from that because most companies have auto-scaling policies in place, which auto-scale based on specific performance metrics. So immediately after you improve performance, you can immediately get the benefit in cost reduction. So this is where Granulate is at the moment. We are a real-time continuous optimization solution, basically allows us to provide to clients with performance gains that automatically translate into cost reduction. So even if a client such as MoEngage is already utilizing all of those solutions on the cloud, on AWS, or with external solutions, it can still get an additional benefit and pretty significant one while using a real-time continuous optimization solution such as Granulate. Awesome. So again, connecting to what Balaji mentioned, so MoEngage were at the point that they pretty much exhausted a lot of their efforts to reduce costs and improve performance because they were so advanced in terms of resources they were using. And they were also had very significant requirements from each solution they want to deal with. So the most important one is the ability to not invest a lot of time and resources from their dev teams and DevOps teams and engineering teams into supporting the implementation of the solution. And the second most obvious one is to not make any code changes, because code changes mean a lot of changes and compatibility changes and testing from their part, which they don't have the resources to do. And with a company as large as fast growing as MoEngage, it's very hard to invest those resources to actually enjoy the solutions, even if there is actual benefits. So Granulate is in a very good position to answer these requests. So first of all, our solution is completely agnostic to the infrastructure the client is running. So of course, on AWS, whatever infrastructure architecture the client is running, whether it's in Kubernetes or in EC2s or in ECS or EKS or EMR, using spot instances or reserve instances or on demands, are all supported and all can get pretty significant cost reduction and performance improvement using Granulate. This is because our solution is located, optimized at the operating system level. So what is running on top of the operating system doesn't really affect the improved performance. And I will again explain exactly what we do on the next slide. Again, installation is super simple. The solution support daemon set installation installed as a pod on each node, Docker installation, CLI, super easy, doesn't require any efforts or compatible changes from the client side. And it's also, as I mentioned on the last slide, completely agnostic to other initiatives the client might be implementing to reduce their costs. So even if MoEngage, for example, use spot instances and use right-sizing cloud hygiene solutions, they can still get, as Balaji mentioned, significant value in terms of performance and cost while using Granulate. So as a solution that get additional value on top of whatever our clients might be using, it's a really good thing to turn for when you exhausted a lot of the resources existing on the market. And the box there on the right, which is most important for teams such as Balaji's in MoEngage, that no R&D effort is required by using Granulate. You install the solution, it optimizes automatically, doesn't need to change anything in code, no maintenance from the client's end, and no configuration changes. So very easy to install and implement. And we go over exactly how the process went. So you'll see how this happens for MoEngage, for example. So how the solution actually works. So Granulate is an agent-based solution. The agent is installed on a machine or a Kubernetes node or an EC2 or a VM. After it's installed, it starts learning resource usage patterns and data flow. And then after learning those, it identifies bottlenecks and contentions at the OS level. Then after activation, it can make decisions to improve or relieve contentions and bottlenecks to improve performance. So how this agent actually does that? So what's the actual magic behind this idea? First of all, we have two modules. We have a kernel and a runtime module. So the kernel module hooks onto resource allocation mechanisms at the kernel level. So CPU scheduler, network, memory accesses, IO, mutexes, and file descriptors. Basically, whatever executes a queue in order to allocate its resources. The agent is then able to learn these queues in real time, and then to, after activation, prioritize queues in order to relieve those contentions to improve performance. So basically, it takes 20-second chunks of data, learns, aggregates a lot of decisions happening at the queue, and then is able to prioritize those in real time to improve performance and make the best scoring patterns you found during the learning phase. So this is the kernel module. The second module is a runtime module, basically implements the same logic as the kernel module, learns resource queues and prioritize them to improve performance, just at the runtime space, as a lot of runtime managers are masking some of those decision-making from the kernel. So JVM has thread management and garbage collection. So in order for us to have, to be able to have a view of the full machine and to optimize to the full extent, we also implement the same logic to the runtime environment. So this is the solution at a very high level, an agent-based solution comprised of two modules that implements the same logic of learning and reordering resource queues and both creating improved performance on the machines. Again, the major factor here is that these types of improved performances or optimizations are not really existing in the market. Most what you see is orchestration at the cluster level, reserving the right amount of resources at the pod and node level, visibility tools that allows you to get full visibility into your cost or spending and how your infrastructure is looking, or changing your instance types and sizes to reduce your cost. But this optimization is happening at a different layer of the stack, so you get an additional significant cost reduction and improved performance on your cluster. Cool. So let's talk a bit about what we did with MoEngage. So again, we were very well positioned to help MoEngage to actually improve performance after they use most of the solutions in the market and were very advanced in terms of the resources they were using. So what we did is we first start by installing the G agent, which is the agent I just described to you. And then basically we started with two ASGs or autoscaling groups to start the learning phase in which the agent learned the workload. So then after about 10 days of learning, we activated the agent. And then Balaji and the team immediately saw significant value on those clusters, which means immediate after activation, immediate reduction in the metrics that they were monitoring. Again, with no code changes whatsoever, the agent was installed, learned the ASG, and then start optimizing each machine on the cluster to actually create significant performance improvement without any code changes or configuration changes or any configuration tuning for that matter. Then after the initial workload, we expanded. After MoEngage saw the value is real and it's significant, we started expanding to, first we benchmarked the result. Me and Balaji went over the actual result. We capture the metrics before the activation of Granulate and the number of instances and cores they had on those ASGs before, and then compare them to the number of instances and the metrics after Granulate and benchmark the results so the MoEngage can actually have full visibility into how the improved performance is looking. And again, after we went through this together and we made sure that Balaji and his team actually sees the improved performance happening on the ASGs, and they can actually realize that into cost reduction. Because again, Granite, what it does is improve performance as a first step, and then this translates into cost reduction when auto-scaling events are triggered to reduce the number of instances in the cluster. So we made sure that the team saw the value in terms of metrics, and then was able to realize that in cost reduction by auto-scaling or scaling in the number of instances on the cluster. So then after the team saw this extreme value on one or two ASGs, we went to an expansion process in which the agent was installed on a lot of different ASGs, more than 30 ASGs on the MoEngage clusters, and then going through the same process just at high scale, letting the agents learn, activated, and then seeing significant improved performance, which allowed them to save a lot in terms of dollars saved, and also the resources that they use were a lot lower in terms of latency, CPU utilization on all of those ASGs. And I think that Balaji can be a testament to that the process is very low touch in terms of their involvement. So it doesn't really require the team to make any changes or to work too hard with our team, mostly to approve the improved performance that we are seeing and to make sure that they are in contact with us to know what's the next batch to install on. But basically, in terms of the resources on the overhead from the MoEngage team, it's significantly lower than most of the solutions in the market. And also the value is pretty significant. Balaji, correct me if I'm wrong.
You're right, Omar. I think, yes, that the value is significantly even better than what we expected. It was great.
And the amount of resources that you and the team needed to invest is, if I remember correctly, pretty low. I mean, you didn't need to change anything, no code, no configuration, pretty much needed to stay in contact with us and to make sure that the performance improvement we are seeing is actually what you're seeing on the infrastructure.
Yep.
Awesome. So actually to show you the actual value or an example to the value, again, we were installed on over 35 different ASGs, each of them getting pretty significant improved performance. Just a few examples. So I give her a snapshot of a few workloads or ASGs were installed on. So S2S, Report Worker, Report API, and Inbox Group. And you can see Inbox Group, for example, you see here a comparison between active and passive machines running on the same workload and compared with Granulate and without Granulate. So the green line here is the instances running without Granulate, so Granulate deactivated, and the orange lines is with Granulate activated. So you can see that the CPU utilization averages on the activated instances, again, running the same load on the same cluster, is much lower with Granulate, about 34% lower, so 62% average on the passive instance, compared to about 41% average on the active instance. And this allowed MoEngage not just to enjoy the improved performance, but actually realize that by auto-scaling automatically the number of instances on a cluster to enjoy reduction in cost. So most companies already have an auto-scaling policy in place. So this will happen automatically, or it will require a change to the threshold of the auto-scaling policy. But again, with such significant improved performance of 34% or 40%, it immediately translates in most cases to automatic cost reduction. And again, not just the CPU, you can see that also latency is benefiting pretty significantly. Again, another major drop from 74 milliseconds on the passive instances, which is the green line here, and the active instances, which is the orange line. Again, this is an aggregation of all the passive machines, all the active machines, and averaging their latency and CPU. And you can see that the differences is massive. So 62% reduction on average of the latency of the active versus passive instances. So again, by leveraging those two significant improved performances, they were able to use that to reduce number of instances to go back to the same performance as before with a lot less machines, about 40% cost reduction, which is significant, taking into consideration that MoEngage is a very advanced customer that already uses a lot of the solutions in the market and already implemented a lot of those to reduce its cost. So as a solution that allows them to get an additional gains, this is pretty massive in terms of performance or percentage of cost reduction. Again, additional workload, this is just a snapshot or a few of them. So report API, all of those are written in Python, by the way. Granite also support Java, Go, Ruby, Node, all supported and get pretty significant cost reduction. And you can see here that report API got a 31% CPU utilization reduction and about 10% latency reduction. Report worker, 40% CPU utilization reduction and 10% latency reduction. So you can see that the performance improvements are pretty massive, and the actual cost reduction that realized by that improved performance is very significant. So I think that the best way to summarize this is that after MoEngage had this problem of wanting to improve performance and reduce costs on their clusters without investing a lot of resources and without changing their code or configuration, they were able to use Granulate as another solution to dramatically improve performance, even though they were already using a lot of the solutions in the market in terms of orchestration solutions, visibility tools, and cost reduction optimization that they have on the market. So Balaji, I think we as we mentioned before, I think that on all 30 plus ASGs, you saw at least some value. Most of them got pretty significant ones. So over 20%, some reaching 40, 50% reduction in cost and CPU utilization and latency reduction. And what do you say was the impact from your side? I mean, what did you saw after each activation?
Yeah, yes, Kumar. So after activating the previously, we have activated, I think, close to 30 auto-scaling group. The outcome was very significant. We were able to see on an average 25% cost reduction in all the auto-scaling groups by average. Not that's the only thing. I think there are factors like the hidden things like choosing the right instance type, to reap the better utilization, right? So that is some of the hidden benefit of what we've seen in this transition. Bad one is say like the previously mentioned, without any maintenance, without making code change. It was a very seamless workaround. Just by only our SRE team worked on this project, and nobody from devs involved on that. So I see on all three areas, I think we reap a great benefit from Granulate, not just saving the cost, and also we realized that how to save cost in the other area, like I said, choosing the right instance type and optimizing the auto-scaling group and policies. So this is where we benefited a lot. To answer your question, yes, by average, there is a 25% reduction in our auto-scaling group by implementing Granulate with our services.
Awesome. So yeah, you mentioned one part that I forgot to mention, that after the initial activation, the Granulate team also provided MoEngage. So me and Balaji discussed a lot on how to change or allocate resources at the cluster level better to actually realize those cost reduction. So for example, changing size or type of the instance, or changing the threshold of auto scaling to actually enjoy the improved performance. Because sometimes when your cluster is auto scaling based on, for example, number of requests, but the CPU utilization after Granulate dropped by 30%, you can get benefit from that while still maintaining the same amount of requests with a lot less machines. So we help the team to actually implement the actual cost reduction using the improved performance that the MoEngage team got from Granulate, which was a very great process, I think. And I think it allowed them to actually realize more than they could by just depending on their existing auto-scaling policies.
Yep. Yes, Omar.
Awesome. So just to wrap up, we discussed today MoEngage first and foremost, which is a fast-growing, very advanced company that is very much competitive in terms of its SLAs and performance they need to provide to their customers. They went through a full journey of trying to improve performance and reduce costs on AWS, leveraging a lot of what AWS has to offer, which is a lot, to improve performance. So Aaron presented a few of those, and we can touch on that as well in a second. And then after going through most of the solutions that they have to improve performance, which they did, they also utilize Granulate, which is a real-time continuous optimization solution, which is slightly different than most solutions you have in the market at the moment, which allowed them to get an additional 25% average reduction in the number of instances and nodes, and even more than that, improve performance. So 30, 45, 50% improvements in performance in terms of latency and CPU without any code changes, very seamless, that allowed them to get additional value on their clusters. So thank you so much, Balaji and Aaron, for joining today. Thank you for your time. And I hope we gave the audience some context into what's the normal journey of improved performance and cost reduction. So thank you so much.
Thank you for that.
Thank you. Yeah, thank you all.